Hello everyone, myself Diksha Gupta from MCA 5th Sem IIPS TVV. Today I'm going to solve my first internal test paper and here is set B and here is a question first which says find the cube root of 12 using fixed point iteration method correct up to 4 places of decimal. In fixed point iteration method we used to find convergence root means by using the formula. So we are going to start it. We know that x cube is equals to 12 and x cube minus 12 is equals to 0. We can rewrite this equation this in the form of equation in which we get x cube minus 12. We can also rewrite this equation in the form of this. We know that our formula for fixed point iteration is xi equals to g of xi minus 1. We are going to apply same formula on this equation and in this equation we know that the cube root of 8 is 2 uh, and cube root of 27 is 3. That means our roots lies between the 2 and 3. Our roots must be lies between the 2 and 3. Let's assume the value of x0 equals to 2. In first iteration we get our value of x1 is equals to 3. And for second iteration we will get our value as 1.33. In third iteration we will get the value as 6.753. In fourth iteration we will get the value of 0.263. We can see that the value which we are getting are not a convergent value, means we do not get our convergence rule. You can say we will stop here and say that we are not getting a convergence rule, so we will stop an algorithm and say we will not get root. So this is our fixed point iteration method. Now moving to the next question. Second question, which says write an algorithm for finding the square root of a 12 using Newton-Raphson method. So we are going to start it. In first step, we used to read x0, e, delta, and n from the user. X0 is the initial guess value, e is the precision value, means relative precision value, and delta is the slope precision value, and n is the number of iteration. In second step, we use for loop, which is initialized from 1 up to n and incremented by 1. In third step, we use our equation as we have to find the square root of a 12. So square root of a 12. So we use to assign our equation in f0, and finding the in fourth step we used to find the differentiation of f0. How to find the differentiation of x0? We know that the formula of differentiation is that the formula of finding a differentiation of for xn is equals to is nx and to the power n minus 1. So here it comes out to be 2x0 and differentiation of s12 is constant, so differentiation of 12 is become 0. So f dash 0 is 2x naught. In this we used to in step 4 we are assigning 2x naught 2x0 in f dash 0. In fifth step, we used to check that our f dash 0 is smaller than or equals to delta. If it's true, if it's true, means then we go to the step 12 and says that a slope is too small and we will stop our algorithm here. If it's not true, then we move to the step 6 and find the roots by using the Newton-Raphson formula. This is a Newton-Raphson iterative formula. In step 7, we used to check the relativeness error. If it's smaller than 0, smaller than e is the precision value. Let's suppose it's 0.001. Then we go to the step 14 and says that we got our convergence root and we will stop the algorithm here. If it's not, if its condition is false, then we used to assign x1 and x0 at x1 and x0. We used to follow these steps again and again till n. When we reach n, then we means a for loop will end and we come out from this for loop and n. In step 10 we say that we do not get convergence rule in n iteration, means suppose in this step if it's not in fifth step we check that it is smaller than delta, then we say that is 2 is small, as we can see. In seventh step, if it's smaller than e, then we say that we get our convergence root. If suppose this equation is this condition is false till n, this condition is false till n, means that we do not get our roots till n iteration or our for loops end, means we do not get root convergence root in n iterations. So in 10 step we say in step 10 we say that we do not get roots in an iteration, and algorithm will be stopped here. So this is a Newton-Raphson method for finding the square root of 12. Now moving to the next question, question 3, which says give the output for Gauss-Jordan algorithm. First, we need to understand what is a Gauss-Jordan algorithm. In Gauss-Jordan, this is the algorithm for solving the system of simultaneous equation. In this, this four column represent the coefficient of the algorithm, and this last column representing the discrete values. If in system By using Gauss-Jordan algorithm, we used to write the equations in the form of matrices. As you can see that this is a matrice, this is a matrices. What we have Now, what we have to do in Gauss-Jordan algorithm, we have to make the elements zero, which are below or upper the value, which are below or upper the diagonal. We have uh, we have to make elements 0 which are below or upper the diagonal, means this element and this element, we have to make them 0. So how to make it as 0? We used to apply this following rules. As you can see here, this following rules for making them as a 0. So by applying these rules, we have to make row 2, row 3 and row 4 as 0. So we are going to take the help of row 1. In same order, if we have to make the elements of row 1, row 3 and row 4 as 0, then we are going to take the help of row 2 by applying some operations. So in first step, we apply some operation with the help and taking the help of row 1, we get our following result. As you can see that the elements which are below the diagonal are become 0. Now we have to make all the remaining element as 0, as you can see there. Now again we are used to apply this following operation, and then we get our this matrix. We are going to apply we are going to apply this operation again and again until we get a roots until we get a matrices which is in which the elements below the diagonal which are and the elements below the diagonals are 0, and the elements which are upper the diagonal are 0. Now again applying some operations, we will get this matrix, and again by applying some operation we will get this following matrix, and this is our final matrix. As you can see that we get 0 which are 0 below or upper the diagonal, uh, and we get our we will get our values. We will get our values. X1 will be x1 equals to 5, x2 equals to 4, and x3 equals to -7, and x4 equals to 1. This is our Gauss-Jordan algorithm for finding the system of simultaneous equation. Uh, so thank you for watching the video.